First part of the lesson is solving absolute value equations. This is like your third go-around with it. You did it in Algebra 1, you did it in Algebra 2. Here's the third go-around. Man, I'm telling you, dude, if like these bars didn't need to be there, we wouldn't type them there. But they totally mean something. You know what I mean? The absolute value bars mean something different. Because if they wanted this equation to be x minus 3 equals 9, they would have wrote it that way. But it is not quite. So what I did was I just start with the basics. I think you're pretty familiar with the fact that the absolute value means make something positive that's inside of there, right? So could you tell me like what x could be that would make this a true statement? What could I put in for x? When I make it positive, it would shoot out 4. 4 would work, right? Is there anything else that could work? Or negative 4. Do you see how there are two answers to that situation? So on homework, please check to see how they want you to type it. Sometimes they've got these brackets around it to where they put it as a solution set, and sometimes they don't. Read the instructions carefully of if they want the brackets or don't want the brackets. Cool. But for me, you should put the brackets around it, because what we forget about is sometimes you can get extraneous answers with absolute value, guys. So what you have to do is you have to substitute these guys back in and see if it comes out right. If I put 4 in for this, when I take the absolute value, yes, I get 4. If I put negative 4 in for this, when I take the absolute value, I get 4. They both worked. They both made sense. When it comes to solving absolute value equations, now we'll get into this. By the way, if you notice, algebra is the easiest way to do this. We're going to do some of these by graphing today as well. I'm going to tell you, these first 4 you will do faster if you do it algebraically as opposed to graphically. It takes too long to graph some of these guys. So what you got to do is notice you have to do this. Are the bars all by themselves on one side of the equal sign? If you go over to number 3 right here, you see that the bars are not all by themselves. There is a times 2 out in front and a plus 3 hanging out with them. You know what I'm trying to say. Are the bars all by themselves? So what we'll do is watch this, just to not insult you, but would you believe if I just covered that up and called it a blue blob for a second, would you believe that if 9 was in there, I would get a true statement? Or if negative 9 was in there, I would get a true statement. Are you with me on that? There should be 2 different scenarios. So what we'll do is whatever that blue blob is, we will take it, x minus 3, and set it equal to 9. Or we will take what's in the bars, x minus 3, and set it equal to negative 9. That is literally just what you told me. This blue thing right here could be 9, so I let it be 9, or it could be negative 9. Cool? And we will solve both situations. So now the bars are gone, right? All we do is add 3 to both sides, and x could be 12, or we add 3 still here, and x could be negative 6. See how quick that was, like algebraically. That is not an algebraic challenge. The thing is, I have to check to see if any of those are extraneous or not, meaning it works algebraically here, but it doesn't work back in the OG. So if I put 12 in here, maybe, I don't know what your Algebra 2 teacher did. They used to make you write out the check. I do not make you write out all your check, but you have to check. Sometimes these answers don't check. So if I put 12 in here, this 12 minus 3 is 9. If I take the absolute value of that, do I get 9 back? So this guy checks. And if I put negative 6 in here, negative 6 minus 3 is negative 9. If the absolute value of that, is it also 9? So both of those check. So that's why I want you to put them in solution sets when we do it on paper. On homework, you got to type it the way they want. But you only put the solutions in the solution set, and both of those guys were solutions. So we'll do one more time here. Here's a thing that you need probably refreshed on. It is illegal to distribute through absolute value bars. Sometimes it works, and sometimes it doesn't. My rule of thumb is just don't do it. We cannot do it, right? Don't do it. So here's what we'll do. We'll get the bars by itself first by subtracting 3 from both sides. So bring all this hog down, and I got me a 16 right there. It's cool with me subtracting the 3 over. Now I want to get rid of that times 2. So I'll get rid of that times 2 by dividing both sides by 2. And you see like the 16 turns into an 8. This is rule 1. Get the bars by themselves. Now take what's in the bars, set it equal to what you see, or take what's in the bars and set it equal to the opposite. What's in here, in this red highlighted region, if I could select the highlighter, is either supposed to be 8 or negative 8. So I'll solve both of those. 2x equals 12. So x could be 6. Add 4 over, 2x equals negative 4. X could equal negative 2. And then one of your first go-rounds with this, a lot of people thought you should throw away that negative. They're like, well, absolute value has to be positive. No, it doesn't. You know, like the absolute value bars make things positive once you substitute them in. So let's do a quick mental check. If I put 6 in here, I'd get 12. 12 take away 4 is 8. Absolute value of 8 is 8. Times 2 is 16. Plus 3. Yes, it checked. And I'll tell you what, so will negative 2. Here's a fact, dude. You should never get extraneous answers in anything like the first 3. Every answer you get should work if you did your algebra right. But can you check out 4? Something is different about 4. What is different about 4 over here? What do you see over there? There's an X over there, right? It is very likely that some of these answers won't check when there's an X on the other side of the bars, on the outside of it. So what do? We'll solve it the same old way. I got to get the bars by themselves, which they are, right? So we'll say 2x minus 1 equals 8x. What you see is what you get. And then set up the other one, 2x minus 1 equals negative 8x. Could you solve both of those for x for me real quick? So I got some weird answers. On the first one, I got x to be negative 1/6. Is that cool with what you guys got? And then the other one, I got 1/10. I can check these way faster than you think because I have algebra experience. Talk to me real fast. If I have something inside of these bars, that orange thing, and I take its absolute value, what will it always turn out to be? Say positive. What will it always turn out to be? Positive. It has to come out positive. If I substitute a negative 1/6 x in, it's got to go in both spots. Who cares what's over here? What will that nugget turn out to be sign-wise if I put a negative 1/6 in there, positive or negative? That'll turn out to be negative. There is no way that negative 1/6 is an answer to this situation because it's going to make this side negative in that case, and that can't happen. So even though algebraically we did nothing wrong, this is an extraneous answer. He's out. To put 1/10 in there, I can just tell you, if you want to trust me, 1/10 is going to check. You can use like 0.1 if you wanted to, and this side turns out to be 0.8, and what's inside of there turns out to be negative 0.8, but you take the bars, and it's going to work. So 1/10 is your solution on that. But on all 4 of those, I still think doing it algebraically was pretty fast, especially number 2. Like that one takes almost no time whatsoever to do if you did it algebraically. But on the 5th one here, ain't no way I want to do algebra on that one, because look what's inside the bars. Quadratic stuff. Are you with me on this? It's got x squareds and all of that. So what we're going to do is we're going to graph it. Grab your graphing calculator, and it has been a long, long time since you put absolute value bars into the calculator. So there is a way to find it on the calculator somewhere. Here's how I've always done it. If you look above the 0 key, it says catalog. The catalog is everything that's possible in your graphing calculator, every function possible, and they put it in alphabetical order. And the very first thing in alphabetical order is absolute value bars. So if I just go straight to the catalog, it puts the bars for me. I have a newer calculator, so it literally has the bars. If you have an older calculator, it'll say ABS with a parenthesis by it, right? So it's got that. I'm going to put x squared minus 5x. I guess I didn't really explain how we should graph this. Sorry. What you do is you graph the left side of the equal sign as y1, and you graph the right side as y2, and you're looking to see where they intersect each other at, right? So I got y1 as that orange guy right here. y2 is just 6. Are you with me on that? I graph the left side as y1 and the right side as y2. And I'm going to zoom 6 it to see if I see what I want to see. I'm looking for where they intersect. And pretty much most of the time, those weird quadratic absolute values make like a W type shape, you know? You see where my red guy intersects that dude 4 different times in that case. So there are 4 answers to this guy. Let's find them. I'm going to hit second calculate, choice 5. I'm going to make this larger so we can see what's going on. First curve, I just hit enter. Second curve, I hit enter. And it's going to go find the value that my cursor was closest to. So it found it at the point 2, 6. Here's my question. What are we solving for? Are we solving for x or are we solving for y? solving for x, so one of our x values was 2. Are you with me on that? Like, the y value of 6 doesn't matter. We wanted to know what x equals. So I'll do that again. Second, calculate choice 5. First curve, enter. Second curve, enter. Now I got to move my cursor closer to another guy. So I went way far to the left, and one of them was -1. And then I just got to do that 2 more times. And you guys can do it faster than me, so if you would just tell me what they are, it would help me. I think one of them's 10. I'm not sure. So I found another one to be 3, and then could you tell me what that last one was, because you guys calculated fast. 6. Cool. Why did I solve that one by graphing? Well, one, it literally told me so. If the test tells you so, I think you should do it that way. If the homework tells you so, which it will, I think you should do it that way. But it's because it was quadratic. And quite honestly, number 4 is probably a good one to do graphically as well, you know, but I just think the algebra isn't that bad. I also want to do a couple more warm-ups with you. What if I gave you absolute value of 2x plus 1 equals -7? That one is called the common sense check. Do you see the bars are all by themselves right here? There's nothing over there. But look at what kind of number that is over there. Is that a positive number or a negative number? Negative? That is no solutions, man. There's no solutions. You could do the algebra all day, left and right. You're going to check them, and they're not going to work. So when the bars are by themselves, if you get a negative over there, there is no solutions. So that's one concept for the day, is solving absolute value equations. The next is variation. This is only your second go-round with it. I won't lie, variation is probably the most realistic thing that this class does. The bad part is we don't have the data to do the variation with. So here's a quick little example of what direct variation is all about. It's like, as one thing increases, the other increases as well. Like, as the temperature outside in May increases, would you believe that the number of people that go outside to the park also increases? Because it's starting to get nice outside, right? So as temperature went up, people at the park went up. You see, they had a direct relationship with each other. As one increases, so does the other in that case. Well, what happens is science collects all kinds of data. I like these scientific ones with a story behind them. It says the amount of bacteria in a dish, they want that to be Y. Here's the magic words. I'd like you to circle it. Varies directly. Like, circle the word varies, and then maybe like underline the word directly, as the square of the number of minutes in the dish, X. That's weird, but they literally like studied it, you know, like we're just taking time. They're like, okay, at 1 minute there was this much bacteria, then 10 minutes later there was this much bacteria, then 20 minutes later there was this much bacteria. They looked at the data and they saw the relationship was squared. So they say after 6 minutes there was 162 bacteria. Find the number of bacteria after 14 minutes. Here's what we do. I will require you to do a 4-step process and number your steps. I've labeled them here in this gray box for you. Step 1 is write the generic equation for variation. And here's the cool part. They're always the same pattern for direct. It's going to be like y equals k times x to maybe some power. So here's what we got to do, though, especially on our homework program, is look to see if the letters they're using are what they want us to use. Sometimes they use X's and Y's, sometimes they use A's and H's, sometimes they use T's and W's. Like, make sure you're using the right letters. Why did I have you circle the word varies? That's where the equal sign is located, baby. Do you see the letter Y is to the left of that? So you will start with a Y. Equals. When they say directly, the next variable will be upstairs. It will not be downstairs. Direct is always upstairs, but there's always this weird thing called this k value. The k value is the constant of variation, so k is always upstairs, and it says as the square of the number of minutes in the dish x. You tell me, should I put a 2 up here, or should I put a square root sign around it if they want it as the square of the number of minutes? Should it be this, or should it be this? Purple one or green one? Which one says the square of it? Purple or green? Purple is squared, green is square rooted. Are you with me? So we want to square this guy. So what's going on here? These bacteria are going on at some crazy rate as x squared, and what we're trying to find is what's the constant of variation? Like, how fast is it actually happening on average? So they studied the data. They had that generic guy. That's your step 1. Step 2 is they'll give you one data point like this. After 6 minutes in the dish, there was 162 bacteria. So we're going to put 6 in for X because that's minutes, and we're going to put 162 in for Y because that's bacteria, so we'll sub that in. But what we don't know is K. We just don't know K. Are you kind of with me? I put 6 in for X, and then I put 162 in for Y. 6 squared is 36, so I really have 36K equals 162. Could you divide that for me and tell me what K turns out to be? Didn't get my worksheet out. What's K turn out to be? 1.5, is that right? 4 points. That sounded weird. 4.5, are we cool with that? So that's what the scientists are looking for. In an example coming up, it'll make more sense. I'm not trying to waste your time, but they were like, man, what's this rate that it's happening at? Awesome sauce, 4.5. Step 3, start over. Use K to write the variation equation. So here's what you do. You take step 1 and copy the whole thing over again. Start completely over. But where there was a K, we're going to put 4.5 in its place. Does that kind of make sense? So Y is going to equal 4.5 X squared. That's what the scientists were looking for. It's like they knew it was happening at a squared rate because they could say after 1 minute there was 4 bacteria. After 2 minutes there was 9 bacteria. And after 3 minutes there was 16 bacteria. Then there was 25 bacteria. Then there was 49 bacteria. You see how it's like happening at a squared rate. But they didn't know this weird constant of variation ahead of time. So they found it with some data. And then step 4 is answer the question, dude. They say find the number of bacteria after 14 minutes. You tell me, dude, where does the 14 go in for? In for X or in for Y? In this case, it'll be X. It doesn't always go in for X. So we will do Y equals 4.5 times 14 squared, and we will punch that in. 4.5 times 14 squared. And did you get that big old number of 882? What's the label on it? 882 what? Bacteria. Weird. That one was lame because not very many people care about how much bacteria is in a dish. It's not the most realistic thing for people. It sure was to the scientists studying COVID and all that spread and all that stuff, you know, but it means something to somebody. But what I like about it is that at least it had a story. Here is a lame algebra problem. I cannot stand lame algebra problems with no context. This means nothing to anybody, but we're still going to do it because that's how they have it on the homework and the ACT and the final. Suppose S, boom, varies directly. So we're going to start with step 1. S is on the left side. Equal sign is where varies is. When they say directly, everything is upstairs. So the 2/3 power of T. But what you always, always, always have to have in a variation problem is the constant of variation, which is known as K. That's my generic formula right there. Then, step 2, right here, let's sub in some data and solve for K. They say when S is 64, T is 64. Are you with me on where this data is? They like gave it to me. Hey, that S is 64 when T is 64. So awesome. S is 64. I'm going to put 64 in for T. And I don't need you to do any non-calculator stuff, even though back in the day you totally could do 64 to the 2/3 power without a calculator. 64 to the 2/3. What does 64 to the 2/3 turn out to be? 16, right? You know, so if I can hit enter, 16. So 64 equals 16K. And now let's solve that guy for K. That's 4, right? Cool. We have found K. Yes. Step 3, baby. Start over. Redo step 1, but where there is a K, we are going to put 4 in its place. So all I did was start over. And then step 4 is answer the question. They say find S when T is 8. Cool. Find S when T is 8. So I got S equals 4 times 8 to the 2/3. And you could literally punch that whole thing in from left to right. Lame. You didn't know what any of this stuff stood for. S's and T's. What are they solving for? What is this? It's dumb. I like stories. Stories at least have context to it. Is it to the 2/3? Is that what we're doing? Yeah. Delete. And did you get 16 back on that? Right? Can't even put a label on it because there's no story to it. Dumb. But that was direct variation. Here's the secret. I'm trying to use a highlighter, sorry. All the letters are upstairs. No one was down in a denominator unless we do inverse variation. And I could tell you my green example up here is the most realistic inverse variation situation you could get. We could all take a trip to the weight room right now and I ask you to bench press. I don't care how strong you are or how weak you are. If you had the bar, right, empty, and you were bench pressing, cool, you could do a certain amount of reps. What if we increased the weight on that bar? Would the amount of reps you do go up or down? They would go down. I don't care how strong you are. As the weight goes up, the reps go down. Are you with me on that? That is an inverse relationship in that situation. As one increases, the other decreases. So here's my made-up story problem that I think makes a lot of sense. The time it takes, in minutes, to clean the bleachers at Lewis Field after a football game, T, we're going to call that T, varies inversely. So we're going to circle the word varies. We'll start doing step 1. They wanted T this time to be on the left side of the equal sign. And when they said inversely, that means we need a fraction bar. It varies inversely as the number of people, P, cleaning the stadium. So the P is downstairs. But guess who's upstairs? K. K always has to be involved. K is that weird constant of variation. K is always upstairs. But I think this makes sense to you, right? The more people you got helping you clean up the bleachers at Lewis Field, the less time it's going to take. Doesn't that make sense? As people increase, the time it takes to do it will decrease, right? That's an inverse variation in that scenario. So here's what they knew. Hey, last week there was only 3 people helping us clean the bleachers, right? It took us 170 minutes. So step 2, time was 170. K, I don't know what that was, but we had 3 people, right? We had 3 people doing it. Are we all cool with that scenario right there? So let's get rid of this divide by 3. Multiply both sides by 3. So 170 times 3. 510 people, or excuse me, 510 is this constant of variation. And of course, we've got to do the caveat, assuming everyone's working at the same rate. Nobody's working harder than others. The people aren't children, you know, because children can't work as fast as an adult does or anything like that. But K is this constant of variation. Step 3, start over. 510 over P in this case. So we start over. Step 1 is exactly the same. But where there was a K, we put 510 in its place. And then step 4, it says, how long would it take if 8 people were cleaning, right? So T equals 510 over 8. 510 divided by 8. 63.75 minutes. I don't know if they're going to have you round to the nearest minute. Yes, they do. They say it right there, round to the nearest minute. So would that take 63 minutes or 64 minutes? 64 minutes. 64 minutes. Again, that's assuming that everyone does their equal part, and it's just a made-up story that makes a whole lot more sense in a realistic situation that says, hey man, the more people that help, the less time it's going to take. You know, that's an inverse relationship. So let's do one last one that is lame because there is no context to it whatsoever. Could you do step 1 for me? Write that generic equation. The equal sign is where varies goes. S was on the left of it. Since they said inversely, inversely means you got to put whatever letters are coming up downstairs. Like inverse is going to be a fraction, right? So you got to go downstairs. They said the square root of T, so I put the square root of T down there. But remember, K's always got to go upstairs. Cool. Substitute some data in for step 2 so you could solve for K. This is 4 when T is 4. I wouldn't cheat that system. Like people are like, can I just put a 2 down there? I understand where you're getting the 2. It is the square root of 4. I would just keep using the square root symbol. You'll end up like not messing up any further. But then you can strike them out and put a 2, you know. And then get rid of the divide by 2 by multiplying both sides by 2. That's step 2. Step 3, rewrite. Do step 1 all over again. All over again. But where there is a k, I'm going to put 8 in its place. In all 4 of these examples, I should probably switch it. They told you this letter, the one that's in the equation. They might give you one of these. You might have to substitute in for the other letter on homework and then solve for the other guy, but they did not. So they put a 16 in there. So step 4, s equals 8 over the square root of 16, which I'm going to strike out and put a 4, and doesn't s equal 2, baby? Direct variation upstairs, inverse variation downstairs. K is always upstairs somewhere.